Hello. You should see my desktop right now. Is that what you're seeing? You see the desktop?
Yeah.
Okay, great, thanks. Yeah, that's what we're gonna well, we'll wait another minute till everybody can come in. There's still people coming in, so I'm gonna wait a minute for starting so that give everyone a chance to enter the meeting. Okay, so what we're gonna do today is try to do just pretty much like we do in the classroom. I'm just gonna have my desktop on display, and I'll run code and look at web pages. If I need to draw a picture, I'll try to draw a picture up on the screen. So we'll just focus on using the desktop just like the projector in the classroom. If you have any questions during the time, just stop me. If you type questions into the chat, I probably won't notice it because there's just too many things for me to be like paying attention to. So if you have a question, just unmute yourself and interrupt me. Just say I have a question. So feel free to interrupt me at any time if there's anything you want to ask. Like I say, but if you type questions into the chat, I probably won't notice it. Okay. So again, if you have any questions at all, anytime, just unmute yourself, interrupt me, and just ask a question. Okay. And yeah, we about 2/3 of the class is here at this point. So I think we'll go ahead and get started. First thing I want to point out is the first exam for this class, is on uh, March 5th. That's 3 weeks from today. So that's 3 weeks from today. So I put up some review problems just to get them up there, but these review problems are only what we've covered so far. So these are review problems about what we've been doing with, today we're going to start doing networking. So we're kind of finished all the stuff about, you know, Java IO, byte streams, buffers, data formats, character encodings. These are the zip files that have the code examples. I didn't put there's also some reading assignments. I didn't put links to them up on this thing, but these are the zip files, the code that we've looked at. So these problems review those kinds of things. These are review problems, uh, and this will be about half the exam will be on this. The other half of the exam will be on network programming that we're going to do in the next 3 weeks. So we're going to start doing the network programming, and in another week or 10 days, I'll have some review problems up there for the network programming. But anybody, if you want, you can start looking at these. If you can start looking at these problems anytime you want. Like if you had other classes with me before, I won't provide solutions to these problems. Don't write to me and ask me what's the answer sheet, but I'll answer any questions. If you want to work with other people on them, if you want to work together on, that's fine. If you want to show me your problems, that's fine. If you have questions about them, I'll answer questions, but I won't answer the question, what's the answer to all these problems? Or what's the answer to problem 7? So I'll look at your answers and I'll talk with you about your answers, and you can work with other people. Think of this as like homework assignment. It's a good way to review the materials to solve these problems. So these are problems involving Java streams, character sets, filters, the stuff that we've been doing. Okay, so you have 3 weeks to look at those, and then when I add more problems to this list, I'll make another little announcement. I'll let you know when this list has been updated with the problems involving networking, which is what we'll start today. Okay. Okay. So again, if you have questions about these, anytime if you want to come to my office hour and ask about them, if you want to, you can email me an answer and let me ask me if this is the right answer. That's sometimes that's what people have done in the past. Some people have emailed me an answer and says, "Is this the right answer?" Sometimes people just come and ask me in office hours and show me their answer and ask if that's the right answer. Okay, so think of these as like, as homework problems to give you a sense of how to think about what we've been doing. Because mostly we've just been, you've had two programming assignments that use a lot of this stuff, but there's still a fair amount of detail these problems ask for a little bit more detail than what the programming assignments do. Okay, uh, let me see. And notice that, I may you've seen this before, but there are links in this thing. It's not a web page, it's just a text document. So for example, here's a link to link if you highlight if you click on it, nothing happens. But if you right click on it, you can say go to. Okay, so there's the picture of the UTF-8 encoding. So this is a text document. You can see up here, it's a text document, not an HTML document, but it does have links in it. So if you double click on this or triple click on it, that highlights it. Then if you right click on it, you can go to that web page. See, so there are links in there. Use them. Some of the problems you'll need the link to be able to solve the problem. So if you see a URL in the document, that's a link to something. Like here's a link to a Stack Overflow question, and I ask you to analyze this. I ask you a question about this answer in the Stack Overflow question. There's something in this answer. It's a little bit ambiguous. So the question here is for you to figure out something about what this guy's saying in his Stack Overflow answer. Okay, so so you need to follow these links. There's maybe 3 or 4 of them scattered through here. You need to follow these links if you want to be able to solve those problems. Okay. Anybody got any question about the nature of the review assignment or the review problems? Anything? Okay. So the exam will be 3 weeks from today. It'll be in class, a regular exam, paper and pencil exam, 3 weeks from today. Okay. All right. So what we want to do is start talking about the code in this networking folder. Okay. Now, I gave you a bunch of reading assignments about networking. I actually added another one here. It's kind of a nice, like this is just a one long web page. It's a nice little introduction to network programming. It's actually it's about 4 or 5. If you printed it out, it'd be like 5 or 6 pages. And you know, the guy who wrote this actually made it into a PDF document. So if you click on this, you can see what it looks like, nicely formatted like a textbook. So there's the networking. Yep. If you like to print it this way, if you like to read it this way, it's just another kind of good basic introduction. Like I mentioned, there's no real textbook on this. Everybody just puts a chapter on networking more or less in the middle of their book on Java, and it's unfortunately there's just no really good. I wish there were like a good overall book on network programming in Java, but I haven't been able to find one. So I think right now I've given you references to see there's this one, and there's this one, 4 of them so far. Four, there's 4. This is the one this is probably the best one. Well, actually, they're all pretty good. So there's this one. They're very repetitive, but not 100% repetitive. Each one has like a little bit of information the other ones might not have. Uh, you know, kind of skim through them. As we talk about things and we learn things, as you read these, if you read these, they'll help reinforce the idea that are most important. Any idea that appears in all 4 of these is a real important idea. Any idea appears in one but not the other 3 is probably not as important, but might end up being a useful fact to know. It's unfortunately like I say, there's no one great place to read about network programming. So right now I've given you 4 introductions. Each one of these is just a chapter in a freshman programming book. That's where every one of these came from. This is the one that we used in RCS 123, 124. This is the guy who wrote the big Java. See, this is the Xi book that we use is this book here. Okay, So this is what the book looked like when it was printed on paper. So this is the PDF of what the book looked like then. It's pretty good. Okay. And yeah, okay, good. So these are just none of them are deep because they're all chapters in a freshman introductory Java book. So none of them are deep, but they do explain the basics of networking a little bit. Okay. All right. Now, to get started, what we want to do is think of networking as an extension of what we've been doing so far, input output. The way to think about that is in this folder, there's a README. This picture here, we're going to remember. Oh, let's see. Let me open a picture that we looked at earlier in the semester. So, okay. Remember we started with these pictures. A process has three streams: standard in, standard out, standard error. And you could, in theory, connect two processes together with a pipe. See, you could have one process write to standard out, and then the input would appear as the standard in another process. Networking is a glorification of this picture here, where the pipe, no, this pipe is one directional. You write to standard out and you read from standard in. The data flows in that direction. Networking is kind of a glorification of that picture. We're going to have a process with a what's called a TCP connection between them. This is the internet. So that's going to take place. That's going to sort of take the place of where is let's see. Okay. We want this TCP connection to replace the notion of a pipe. The biggest difference is this is bidirectional. Whereas data only flows in this direction over here, this TCP connection is bidirectional. It's really as if you had two pipes over here. If you had a pipe moving from left to right and a pipe from right to left. But the key is that this is a stream, and so is this. Well, this is two streams. This is one stream. This is two streams. Okay. But this is streams taking place inside of one operating system. The pipe is just happening inside the single computer. It's the operating system that copies data from here to here. When you send data from here, you actually send it to the operating system. Then the operating system copies it into a buffer and makes it available to this process. So this all happens in the memory of one single computer. Here, this TCP connection, we're going to make it from our point of view of our program, it's going to be a stream, but what's happening inside here is a network connection where data travels around the globe over over the what we call the internet these days. We're just like over here, we didn't really say much about what the operating system is doing. This isn't a class in operating systems. So, as programmers, we use these pipes and we don't need to know a whole lot about how they work. We need to know a little bit about the buffers that were involved there. Remember, if you don't flush the buffer, you could have data just get stuck over here and never make it through. You might have to flush the buffer. So you need to know there's a buffer there, and you need to know you might need to flush it. But if you ask how does the operating system, like how big is the buffer? How does the operating system detect the buffer? Where does the operating system store the buffer? You don't really need to worry about that. Over here, we're not going to worry too much about what the network actually is. In an engineering class, like a computer engineering class, they actually talk about what the network really is. What are the routers? Is it an Ethernet network, an ISDN network? Is it a wireless network? It's a network's made up of what are called switches and routers. In this class, we're not going to talk about the physical network. We're really going to emphasize the coding. So we're going to treat it as a course in coding network code, not building physical networks. So this is just going to be a network connection. This is going to be a network connection that connects two processes. We use the word socket to represent the process. And what we want to do is kind of talk about this idea a little bit. Yeah, over here, a pipe was basically that symbol on the command line. You know, the pipe was that symbol on a command line. Okay, here we need to talk about what, from our point of view, where do you get network connections? You get a pipe by using that symbol on a command line. Where do you get network connections? What's the syntax for creating a network connection between two sockets? Okay. And the answer has to do with URLs, at least at the first level of approximation. We're going to talk about things. We're going to talk about things step by step. We're going to talk about we're going to build up to a general idea. If we go back to this page here, let me see. There was a nice picture in one of these. See, there's people. See, there's a picture like there. This is the connection. See how they show two arrows? So that those two, this thing here is what we mean by an over here. This see this would be the computer on the left. This would be the computer on the right, and this bidirectional communication is what we call here the TCP connection. So this is a very abstract picture of it. Here's a little bit more realistic, something to give you a better sense of what this is. Uh, uh, I think the other book has a similar kind of picture. Okay, here's a computer, here's another computer, here's that network connection between them. This is supposed to represent the different servers and routers and network. This a lot of times people use a little cloud symbol to represent the network from this side to this side. They just basically say your data travels over the net over the internet and goes to somebody else. Okay, this is how you might think about this. You know, this is a very abstract way to talk about two computers connecting over the internet. So this is our very abstract picture of two computers talking over the network. This is another picture of it. And probably each one of them has the same idea. They want you to think in terms of uh, not that, here this picture shows you lots of computers. In a sense, the network isn't just two computers. They're actually connected all together. And this is just showing you that you can connect them together in different ways. We're not see This is what we're not going to really worry about. We're not going to worry about this. Is more talking about the actual physical way computers can talk to each other. So these are called network topologies. We're going to kind of abstract it, so we pretty much only talk about one computer talking to another computer. That's a network connection, one computer talking to another computer. So at any given time, one of these is talking to another one of them. That's what we're going to emphasize. So we're not going to emphasize these types of pictures so much, like this. We're really going to emphasize, okay, here, this is even a bigger scale. This is talking about uh, this is the idea that one city can talk to another city, that can, you can have these are referring to the idea that you can have uh, like Purdue Cal's campus connected to Purdue West Lafayette's campus connected to Indiana University's campus. That's what a picture like that is. We're not going to talk. Here's the picture we are. Two computers, we're talking to it. So this picture here is the one we're talking about. There's the one of the two computers. There's the other. Usually one of them is going to be called the server and one's going to be called the client. In this picture, we'll see it as we get along. We'll almost always identify one of these two as the server and one of them as the client. And they talk over an internet connection in bidirectional. See, this shows two arrows. Here I just show it. This thing here, you're supposed to remember that this means a TCP connection, an internet connection means two directions. There's two streams. These arrows are, from our point of view, that's a stream. That's a stream. Okay. So so there's the stream. There's the two streams bundled together. Here he shows it as two streams, one stream going that way, one stream going the other way. Okay. So we want to start talking about this idea of like how do you identify this computer and how do you identify this computer? Yeah. So you notice he doesn't have anything in here that says like what's the name of this computer. He just says that computer A, computer B. Here he just says server and client. Okay. Well, it turns out that there's a very specific way of giving these guys names, and let's see. And there's not a good picture of it. There's another version of this same picture. There's another picture version of this idea here of two computers talking over streams. Okay, see, he has the word socket there and socket there. See, that's this. See, that's a socket and a socket. Okay, and what we're going to say is he explains it in words here. A socket is essentially a IP address and a port number. Okay, he it's explained in here as you go along. A socket is a TCP connection is two sockets, one on each end. A socket is an IP address and a port number. What we'll see is the IP address is that computer. That IP address, every house has an address, right? Well, every computer on the network has an address called its Internet Protocol address. I almost always will say IP, but IP stands for Internet Protocol. Every computer on the network has an Internet Protocol address that's essentially it's not true to say that every computer has a unique IP address, but we'll say it. Everything we tell you in computer science classes is a lie. We are always lying to you because we're always trying to oversimplify things because the truth is always way too complicated. So we will say that every computer on the network has its own IP address. That's not true, but we're not going to worry about the details of it. So every house has an address, every computer has an IP address. So the IP address says that computer, the other IP address says that computer. But on this computer, there could be a mail program, a web browser, a program that's streaming a movie. There could be this computer can be talking to lots of other computers simultaneously. So in a sense, you could actually draw this picture saying he's talking to him and he's talking to somebody else. Like he's talking to the mail server and he's talking to a web server and he's talking to a game server and he's talking to a streaming movie server. So he can be talking to multiple servers, and each one of those is a different program. The browser talks to a web server. Your mail client talks to a mail server. Your game will talk to a game server. If you're watching a movie, your movie program will talk to a streaming service. The program is the port number. The port number is our fancy way of saying there's a program on this computer that's talking to a program on this computer. So that would be this computer has one program that's a streaming client talking to another computer that is connected to it as the streaming server. So on this computer, I identify an end of a TCP connection by saying the computer has this address, and then the port number is an ID number that says which program is the stream, which program. Now that kind of goes back to this picture here. No, I'm sorry. Oh, I closed it. Oh, let's see. Where am I? Yeah, see back over here. Remember, these streams originate in processes. This is a program. This is a program, a process. Here you pipe from one program, one process to another. The port number is an ID number for the process, but it's not the process ID number that processes have like in Task Manager. It's not the process ID number. It's a different way of identifying processes. So over here, When we say a TCP connection is the one side is an IP address that identifies a unique computer and a port number that identifies a unique process running on that computer. That puts the streams inside of a process. So then this thing will be two streams, an input stream and an output stream. And at the other end will be a specific computer with its IP address and a port number, which is the process. Um, I can show you IP numbers, for example. What I'll do is I'll open up a CMD and I can run a program called NSLOOKUP. NSLOOKUP lets me look up the IP address of different computers. So, for example, Google has a whole bunch of IP addresses. These are IP addresses, these things down here. Google has a bunch of servers. They don't just have one. So I'm getting 1, 2, 3, 4, 5, 6 IP addresses. When I Google something and I call Google, I'm actually talking to any one of these 1, 2, 3, 4, 5, 6 computers. Google gets a lot of traffic, so they can't just get away with having one computer. So basically, what when I Google, my computer will randomly pick one of these 6 IP addresses. That'll be the program, that'll be the computer that I'm going to talk to. PNW has an IP address. When you go to PNW's web server, you can get it. Actually, could be any one of those IP addresses. Let me try one of these. Okay, I'm going to take that IP address and I'm going to copy it. Okay, I just copied it. Now I'm going to go over here and I'm going to type that IP address into my browser. See, it turned into pnw.edu. See, so pnw.edu, that's the nice name. This is what's called the URL or the host name. But the internet doesn't really use it. The internet really uses these things. And this NSLOOKUP program lets me translate from the nice names to the real addresses. Okay, IP addresses are what are called dotted quads. There's 1, 2, 3, 4 numbers in there, and there's periods between them. We won't really worry too much about, well, where did this come from? Like the meaning of this dotted quad won't be very important to us, but an IP address is a dotted quad. If I just change that number, like change that 8 to a 7, that's probably still Purdue Cal. Maybe not. Maybe, okay. Maybe if I just if I randomly change one of these numbers, might have to wait a little while. See how it's trying to talk to a computer at that address. More than likely, there is no computer at that address because I just kind of randomly changed an address. And eventually the browser is going to say, I couldn't reach the other end of this connection. It's taking a long time. There, finally. See, the site can't be reached because I kind of just made up an IP address, and there aren't computers at every IP address. So if you just sort of make up IP addresses, you're going to end up usually on something that doesn't exist. Like here's another IP address. This time I got some kind of error message. I don't know why. I don't know. Um, I'm not sure why I'm getting error messages. Because I'm typing it in the wrong place. I'm searching for these IP addresses. If you want to type in an IP address, you type it in up here in the address bar. That's where you type IP address. I was just kind of being dumb and typing it into the search bar. This is called the address bar up here. You type IP addresses up there, but I'm making up IP addresses. They're not legitimate ones. Okay. Now on your hand, if I type Microsoft.com, now that's a name. That name means some IP address. Eventually, see, I got Microsoft's website. What IP address was that name? NSLOOKUP will tell me, well, it's one of these IP addresses. Like, let me just copy one of them. let me just pick this one. Oops. So I'm copying that IP address. I'll go up here and I'll type that IP address. Whoops. Oh, that wasn't a legitimate one. Did I copy it right? Let me try one of the other ones. These are Microsoft doesn't have to be using all these IP addresses at the same time. So even though these IP addresses resolve, we say they resolve to Microsoft, it doesn't mean that they're currently using them. Let me try another one. Well, that one wasn't a valid one either. I don't know which one of these it's currently using. Notice that Purdue Cal did use that. Yeah, I don't know which one. It might be using one of these other. I don't know if it'll. These are slightly different forms of IP addresses. It might be using one of these. Let's just try one more. Yeah. Oh, I typed it in the wrong place. No. So I'm not the Microsoft IP addresses aren't quite working well, but the Google the PNW ones did. Let's just try one of the Google ones. Just give it one more try. Try one of the Google ones. You're not supposed to use IP addresses directly. See, that got us to Google. See, that one Googled. That IP address did go to Google. See, see how the IP address turned into it resolved. We say the word is it resolved to that IP address resolved to that name. You're not really supposed to be using IP addresses. You should be using names for computers. Okay, so the name or the IP address is this end. Okay, now what my computer has an IP address. Like I'm sitting at a computer here right now. Well, what's my IP address? There's a website that'll tell you what your IP address is. Like I actually can't easily figure out what my IP address is. It's a lot easier for somebody outside of me to see what my IP address is. My IP address is 107.192.137.5. Okay, that's my IP address. Okay, so you could type something like that in, but notice I had to go to a website that would look at my computer from the outside and tell me what IP address I'm at. So when I talk to Google, my IP address is over here and Google's IP address is over here. Now, what port number am I using? Okay, when I talk to a Google web server, like here, these are always port 80. Okay, web servers use the port number 80. Mail servers use some other port number, maybe 21. I don't remember what port number mail servers use. Game servers, you can look, there's a Wikipedia page that'll tell you what port number different game servers use. Okay, so now over here, when I talk to a web server, there will be Google's IP address. There will be port 80. Or if I talk to the PNW server. So for example, if I go over here and I talk to PNW, okay, over here was PNW's IP address and port 80, because I'm talking to a web server. Over here would be my IP address. This would be a random port number. When I'm talking to a server, we'll see it, we go along. Over here will be just a random number that my browser will have picked. My browser will have generated a random port number and use it to talk to Google, or in this case, you talk to PNW. Okay, so at the top level, what we're talking about is trying to replace this picture, process talking to another process. Here, process talk to each other over streams. In a stream, the stream is like we said all along, streams are just array of bytes. The same thing's gonna be true over here. These streams are just array of bytes, though these TCP connections are two streams, one stream going from left to right and one stream going from right to left. We want a way to create streams between computers that aren't connected to each other. Here, process and process, the foo and bar are on the same computer. and the pipe is the operating system as the middleman between the two processes. Now it's going to be a process on one computer talking to a process on another computer, possibly thousands of miles apart, connected by what we think of as the internet. The TCP connection is we actually, this concept of TCP connection is kind of unique. If my computer and my process is talking to another computer and another process, that TCP connection is actually uniquely identifiable in the whole planet, because there'll be only one combination of that IP number with that IP number and that port number and that port number. That represents me talking to him on a certain, as from one process to another process. That's actually unique. A TCP connection is actually unique. Okay. So right now, if you looked at like the fiber optics running under the ocean, the fiber optics would be carrying billions of these TCP connections, and the data flowing over those fiber optic cables, each piece of data knows exactly which one of these TCP connections he's on. Every piece of data flowing over those fiber optic cables, and there's billions of pieces of data, they actually know which one of these TCP connections they're on. In fact, they actually, remember, go back to the first homework assignment. I'm sorry, not the first homework assignment. If you go to the second homework assignment, you're dealing with a data structure here, a message. Remember, I told you that there's these examples of that's a packet of information that would be flowing. That would be one message flowing through a fiber optic. And see, it knows the IP. This source address is an IP address. When it just that's the IP address of one end. So if a packet's traveling from here to here, the IP address of this end shows up here. The IP address of the other end shows up here. Okay. Now, what about the port numbers? Well, the port numbers show up in this other packet. This packet would be attached to the other packet. So this packet would say, I'm coming from this computer and I'm going to this computer. This other packet would be attached to this packet. This other packet says, on that computer, I'm coming from this process, and to that other computer, I'm going to that process. So a message traveling across a fiber optic is a combination of these two packets, and it would carry the IP address of the source, the port number of the source, the IP address of the destination, the port number of the destination, and that information would identify the message globally. If that packet's in the middle of the Atlantic Ocean, it's got enough information to say exactly where it came from and where it's going to. The packet would have exactly which computer in the world, let's see, exactly which computer in the world it came from, exactly which computer it's headed to, and what process on that computer it came from, and what process on the other computer it's going to. You combine those two packets into one message, and you have this internet, you have a internet connection. You have a TCP connection. So you notice that this was called the TCP header format. Okay. This guy combined with the IP header, the IP and the TCP. If you ever heard people refer to the internet, you may have heard them fancy talk about TCP IP. You know, if people who are talking, who know their stuff, don't talk about the internet, they talk about TCP IP. That's the combination of one of these messages with one of these messages. That's how the modern internet works. You combine a TCP message with an IP message. That gives you a internet TCP connection. That's the modern internet. Okay. So this information globally identifies a message. So if that message is in the middle of the Atlantic Ocean, it knows exactly where it came from and exactly where it's going because it's got all that information built into it. Now, we don't work with source ports and destination ports, and we don't work with source address. Remember, address means I wish they kind of put in here source IP address, but since this is about the internet protocol, they probably thought it was redundant for them to put IP in that wording. But this is the source IP address, and this is the destination IP address. So they just didn't put the IP in there because they probably thought it was redundant because you're reading the document that describes the IP protocol. But you know, these packets carry enough information that they identify a connection, a stream, a stream. Um, any one of these packets is traveling just in one direction. So remember I said that this is two streams. It's a stream going from here to here and a stream going from here to here. But if the stream is going from left to right, then it's got this is the source and this is the destination. So that would identify a packet going that way. So any one of these messages is only part of one of the two streams. And you have to look at where, you look at the source address. So that means that packet came out of one of these and is heading towards the other one. So any given packet is part of one of the two streams, either heading in that direction or the other direction. Okay. All right. Now, we're going to eventually look at is how do we write code to create these guys? Now, over here, how do we write code to create one of these guys? Well, you wrote that vertical bar on a command line. Okay, that was the code. That's a little piece of code. The code is in the language of the command prompt, but that's the little code that signifies that the operating system should build one of these data structures. It's going to take a little bit for us to find the code that creates one of these TCP connections. It's not something as simple as one little bar. We're going to have to write several lines of Java code to create a connection. But your browser does it all for you automatically. So, for example, this right now, there's the address that I want to do a TCP connection. This essentially embeds a whole bunch of information in it. This is the computer I'm talking to. This is the stream of data that I want to get from it. I'm actually downloading a file from that. What this computer is doing is this computer, I'm talking to a certain process in that computer, and that process is dumping this file in my direction. So there's a lot kind of going on here, but that's all done for me by the browser. I can put the port number in here. Oh, didn't work. Oh, that's right. They're not using, I'm sorry. Port 80 is the old port number. See, this is HTTPS. HTTPS doesn't use port 80. If I switch this to HTTP, HTTP uses port 80. There, see, notice that the port 80 went away. Okay, so we're going to see that when you use what we call the HTTP protocol, by default, that means you're using port 80. But if you use the HTTPS protocol, I don't remember the port number that HTTPS used. Anybody remember it? Some of you may have seen this stuff before. Yeah, I do not remember. Let's see, I can just do, let's see. 443. Okay, so see if it works. If I go over here, see right now I'm doing HTTPS. If I say port 443, colon number is a port number. On the left of the colon is an IP address, but I'm using the name of the IP address, not the actual number. But there's no name for these ports, so I'm using port 443. See, it worked. See, port 443 was, see, but that's the default port, so then the URL erased it from it here. So port HTTPS is using port 443, and HTTP is using port 80. What I'm specifying when I do that is I'm specifying an endpoint. I'm specifying the end of my TCP connection. I'm giving the IP address, but I'm giving it in its high-level name. I could maybe, let's try this. Go here, copy this, go here, see if this guy will tell us what the IP address is. Okay, I don't know if this is going to work. Okay, I'm going to try that IP address with the port number. I'm just going to try using the IP address and the port number directly. So I'm going to take that IP address. There's the IP address. The port was 443. And I did talk to the server, but the server didn't really like what I'm saying here. So that did create a connection, but that connection returned a bad request response. There's something a little bit not quite right about it. But if I did talk to that server, I created an endpoint. Where did it go? I created an endpoint. I had an IP address and a port number. I created an endpoint and I tried to connect to that endpoint. If this is me over here, I tried to connect to that endpoint over here with an IP address and a port number. And I did connect to the endpoint, but the endpoint didn't like what I was saying. Could be because I didn't say anything after it. Like, let's see, I go back over here. Try taking this and putting it on the end of the message. I don't know if this will fix it. Still didn't like it. Okay, still now it could be I'm using the wrong. I got a bunch of different. I got 2 IP addresses here. I don't know if the other one might work.
Yeah, that looks like the IP address for the HTTP protocol for that web page. There might be one of those other IP addresses might be for the
Oh, so maybe
HTTPS
if I try
protocol.
port,
Yeah.
maybe I should try port 80 then. Let me try port 80. See if it likes port 80 better. I got a different address. Yeah, I'm not quite doing it right. Okay. It's really hard to use IP addresses directly. You're really not supposed to be using IP addresses. So when I do this NS lookup and I get these IP addresses, there's no guarantee that they're really the right IP addresses to be using to talk to their web server. Yeah. So I don't know what, yeah, I'm getting connections, I'm making connections, but I'm not making connections to who I really want to make a connection with. Okay. So when you're up here, that's the computer. The port number by default for HTTPS is 443. The port number by default for HTTP is 80. So the browser puts that port number in for me unless I say otherwise. Like if I say HTTP and they say port 88, I'll get an error message. It's going to go to that IP address and say, do you have a port 88 available? And the computer is going to say, no, I don't have a port 88. So eventually it's going to come back with a not found message, some kind of message. But I went to that same IP address and said, I went to that same IP address and said, do you have a port 88? And it's going to say, no, I don't have a port 88. Now, there's a tiny chance that it is running some process on port 88, but it's very unlikely. If I wanted to, I could have a process running on every single port on my computer. I could launch a process on port 80, a process on port 81, a process on port 82. So eventually it timed out because there was no process on port 88. Okay. So there's the IP address : port number. There's the one end of a TCP connection, and I'm the other end. So I'm trying to talk to some other computer. Okay. Now let's switch to some code and look that we can play around with some of this stuff. in this folder, for example, there's a IP address Java program. Java can let you manipulate. Well, this is essentially the NSLOOKUP program. You give this program a name, and it's going to come back with the IP address. So, for example, now what it wants is it wants the name, just like it's essentially a baby version of this NSLOOKUP program. So it's just a few lines of Java that do essentially what NSLOOKUP does. So I compile it. And then when I run it, now I'm running it in TextPad, but see, I have TextPad pop up and say, you want to give a command line argument. Well, I do want to give a command line argument. What I'm going to do is I'm going to copy and paste this like google.com. So I'm going to run it. And I'm going to say, okay, my command line argument is google.com. My program is going to run. It's going to say, finally, there's the IP addresses. More or less the same answer that NSLOOKUP gives. What the program did was what I did was I typed the command line argument. See, find where it is. Oh, here it is. See this for loop. It's iterating on all the args. So I typed only one command, like here, let me run it again. Google.com, pnw.edu, Microsoft. Okay, I'm typing in I typed in 3 command line arguments. So this for loop is going to iterate on all 3 of those command line arguments. Google.com is the first one, pnw.edu is the second one, Microsoft.com is the third one. For each command line argument, it's supposed to be a host name. Okay, so that's a host name. It's the name of Google's host or Purdue's host or Microsoft's host. Okay, it's going to ask, here's where it asks for the IP. See, it gets the internet address of it takes that host name, looks him up by his name, and gives me back his IP address. So I get back an internet address object from Google, from Java, that stores the IP addresses of that host name. So I tell Java, look up the host name and give me back an internet address object. Okay. Then I'm going to print out the internet address object I got back from it. Then I print out the address as host name. I print out the address as canonical host name. Then I print out the address of IP addresses. Over here, cool. Takes a little while for it to run. It takes a little while for it to ask these questions. So it did Google. Now it's doing PNW. Now it's doing Microsoft. Okay. For each one, see that name there? That name there is the host name. That name there is actually like a hidden name. Every one of these guys has a hidden name that's called the canonical name. Okay. The canonical name is the name of the actual machine that server is running on. So it's dc03-cal.pnw. What do you think the cal stands for? We're not supposed to say it anymore. It's what?
Calumet.
Yeah, Calumet, because this used to be Purdue Calumet. And you see that in the networking substructure of the university, it still has cal everywhere. It doesn't have PNW in places. Now it's cal.pnw.edu, but that cal is supposed to identify this is one of the machines that runs at Purdue Calumet. So that, I don't know what the DC03 is. I don't know what their naming convention was. So I'm not sure what the DC03 would stand for. but that's called the canonical name of the computer. That's the actual computer itself. Like this host name, one day they might replace that physical computer with a different physical computer and give it a different name, but pnw.edu will still be running on, will be then running on a different computer. Then it gives me the IP address. So there's the IP address of that machine. Okay. Then it does it again. It gets a list of addresses. Yeah. Then I get essentially, then I can see I do it again and I get a list of addresses. I don't remember what this list is, but this is the list. This is the address of that canonical name. I think these are all the possible IP addresses that computer could be using. Okay. So you see, it kind of does it, it takes Microsoft. Notice that its canonical name, it didn't have a canonical name. Okay. See, this one had a canonical name. You could see the name was different. This one doesn't. The canonical name was just another IP. The canonical name was just another IP address. Okay. Let me do another one here. Now here's something. Here's how you can find out what in the world's going on. SWAPI stands for Star Wars API. The Star Wars API is a toy little API that's used for playing around and learning how the internet works. So if I do, there's the website for the Star Wars API. Okay, where's this web server running? Well, nowadays, almost anybody is actually using AWS. And how do I know that they're using AWS? The canonical name of that server is AWS. It's an EC2 image running on AWS. EC2 is the names of the, when you rent a CPU from Amazon, you're renting what's called an EC2 CPU. So this is CPU, this number. Oh, you see something else? Anybody see something? If any of you have seen it before, see if you know, what else can you get from this line of code here? It's running on Amazon Web Services. It's an EC2 image, but there's something else that's kind of neat there. What else? Does anybody see it?
I mean, it's kind of showing a location
Where is it?
somewhere in Central Europe.
Yeah, in Central Europe. EU. The Star Wars API runs out of a computer somewhere in Europe. So whoever set this up is probably a European, not an American. So it's running somewhere in Europe on an Amazon computing center. It's in Europe Central 1 computing center. If you look this stuff up, Amazon Web Services has about a dozen of these central warehouses scattered around the world. And I think there's 2 or 3 of them in America, and there's a couple in Europe. And if you rent an EC2 image from them, it'll be hosted in one of their main computing centers. So this one's hosted in Europe. Okay. Notice that you don't know it. That's the name that they tell people to use. Let's see. If I take that name and I do over here, see, that's their computer. Their computer is EC2 image 5258 110 120 EU Central. Yeah, that's the computer that's actually running. So what's this? This is an alias. This is an alias for this. That's the actual computer. This is just an alias. Just like pnw.edu was an alias for the actual machine that was running. See, there's the actual machine running the PN. That's the actual physical computer that the PNW web server is running on. That's the name that we tell the public to use. If we replace that computer with another computer, that name will resolve to the new computer. Just like this, if the guy who runs this website moved to America and decided he wanted to move from the European Amazon Web Service to an American web service, he could change which machine he's renting, but he would still keep that name there. And there's a way for these names to be matched up. There's a way for that nice name to be matched up with that actual name, but that actual name really represents that IP. Oh, let's just try that IP address now. Take that IP address, go over here, and see, still them. That's what the internet uses. This is translated to this, which is translated to this. So when you connect to this, what you really do is that gets translated to that, but you don't connect to that guy. That gets translated to that, and then you connect to this. The IP, if we go back to our picture over here, an internet connection is an IP address, not a host name. What we see here is that a kind of an abstract host name can be tied to a more concrete host name, which represents an IP address, and that's really the computer. If I change that IP address, if I change that IP address to something random, more than likely there's nothing there. See, more than likely there's nothing there. Okay. So you really don't ever really know what you're talking to. If you just generate random IP addresses, more than likely there's nothing at the other end of them. That IP address probably belongs to Amazon Web Services, because I took a Amazon Web Service IP address and just made a small change to it. It's probably still an AWS address. If you punch in random IP addresses, you might land on somebody's website. That's what hackers do. They literally scour the internet looking for they don't know where everything is, so they just search for things. They have automatic bots that type in millions of IP addresses, see if there's something at the other end, and if there is something at the other end, what is it? That's hacking 101. Punch in random IP, you write programs that do this. You just scan random IP addresses. Every once in a while, you'll hit on a real web server. Then you start asking the web server questions to see if there may be anything on it that would be interesting. That's how hackers can discover the presence of servers that companies thought were hidden, or servers that aren't very commonly used. You just type in random IP addresses and see what comes up. I'm sure that IP address is owned by AWS, but at the moment, it's probably not being used by anything. You can just keep trying. I mean, there's a lot of IP addresses. You have to try usually hundreds or thousands of them before you land on one that's actually in use. They're not densely the address space is not densely populated. It's what we call sparsely populated. There's lots of IP addresses with nothing there. Okay, so notice that right away, when you start writing your own code, you can start finding interesting things. Like by writing our own code and printing out the canonical host name, we found out that these guys are running in Europe on an EC2 Amazon Web Service computer. Okay. And we found out that PNW is just running on another. Notice that PNW is not using Amazon Web Service. I bet a lot of schools by now are. I wouldn't be surprised if a lot of universities have just moved their websites over to AWS. But Purdue's got a long tradition. Purdue was one of the original. Purdue University in West Lafayette was one of the small number of schools that created the internet. They actually are one of the original websites of computers on the internet. So Purdue has a long tradition of hosting everything on its own. So it probably just out of habit, Purdue is probably never going to put anything up on AWS, but we'll see in the future. They might find it cheaper to just run their website on AWS than to host it themselves. So right now we're running our own web server, right? I'm sure that machine is. I bet that machine's. I don't know if it's on our campus or West Lafayette's campus. I don't know right now. It used to be that machine was on our campus, but I believe they've moved that machine to West Lafayette's campus, but I'm not positive. Even though it's got a pnw.edu URL, it might actually be on West Lafayette's campus by now. It used to be on our campus. I don't know where it is right now. Okay, but when you write your own code, you can start asking questions that aren't easy to ask otherwise. Okay, now here's another program that we can run. What this program does, it doesn't actually connect to any computer on the internet. It just says, give me a URL and I'll break that URL up into its pieces. I'm going to do what's called parse the URL. Okay, so I compile this program. Now, we've said that that is actually represents the IP address of the host. Excuse me. This is the port number. What this represents is where on that web server to find the file that I'm interested in. So I'm talking to a web server, so I want to see a web page. So this says, here's the web server. That web server is using port 80. It's my account with this subfolder, and then here's the file I actually want. Now, when I parse the URL, it's going to tell me all that kind of stuff. So what I'm going to do is I'm going to compile the program, and the program expects the URL as a command line argument. So I'm going to copy, I'm going to run the program, I'm going to give the URL as command line argument, and then see, it told me, well, you're talking in HTTPS, you're talking to the computer cs.pnw.edu. Port 80. Notice that's called an authority. Notice that's the CPU and the port number combined. They call that an authority. I'm not logging into the computer, so there's no user information. There's no user info, so that's null. The host, that's part of the authority. The host is cspnw.edu. The port, which is part of the authority, is port 80. The path to the file I'm interested in is there. Okay. There's no query in here. We'll see what a query is. A query is when you look up something when you ask the web server to look up something for you. Notice that this little piece over here, notice that this part didn't show up as part of, this is not technically part of the URL. Actually, this is not a URL, this is a URI. There's the URLs and URIs, which are really confusing differences, but we'll see in a minute. Notice that it did not even look at this part here. That technically is not part of the URI. Okay. On the other hand, let's try this one here. See this question mark? The question mark says I'm Googling what comes after this. This is the query. The question, see here it says the query was null. This guy didn't have a question mark, so this URL did not ask any questions. This URL is Googling for the it's actually Googling PNWCS, like if I take this URL and I type it into my browser, it's the URL for looking up. See, I searched the internet for PNW CS department. So the first thing I get is the CS department's homepage. Notice I didn't ask for the CS department's homepage. I said Google, search the internet for references to the PNW CS department website. So I got a bunch of pages that are references. So I'm searching the internet for PNW.CS department. The question mark says, yeah, that's the thing I'm doing. I'm searching. And then to the right of the question mark is the Q for query. I'm querying Google. The question mark means actually do the query, and then Google, the Google names this query Q. Yeah, you don't have to name it Q. You can name your query Bob if you want. The question mark says this is the beginning of the query, and then Google says I'm looking up for PNW CS. Notice that the pluses represent the spaces inside here. So I did a query for PNW CS department. Now, if I parse that URL, so I take that URL, copy it, run this program. My program, whoops, what did I do? This program parsed the URL for me. The scheme is what they call the scheme is HTTPS. That's the protocol. The authority is google.com. There's no use. I'm not logging in, so there's no user info. The host is the same as the authority because I didn't put notice that the port number is -1. That's saying it to use the default port number. The default port number was actually 80, but it's not in the URL. So but my browser would know to use port 80 because I didn't specify the port, but the parser is saying there is no port, so it returns a -1, meaning that URL didn't specify a port. The path is search, and then the query is Q equal PNW plus CS.department. So that's the parsing of the URL. So Java knows how to take, if you're writing your own web browser or web server, we're gonna see later on, we're gonna use this code to, if somebody types in a complicated URL like this, Java will parse it for us and tell us the pieces of it. Okay? Like this is another one with a query string. We're calling the Star Wars API. The path is this, and the query string is format equal JSON. Actually, that's not even really technically a query. That is telling the swappy that we want the output in JSON. Like, here, I'll show you what I mean. If I take that URL and type it into my web browser, what I asked for was the third person in the Star Wars universe. The third person in the Star Wars universe is R2-D2. The second person in the Star Wars interface, in the Star Wars world, is CP3O, 3C3PO, okay? And one is Luke, okay? But I want the format in, see, this is a JSON file. See, the browser will format it for me. If I don't want the file as JSON, if I take out that's not really a query string. That's just telling the API what format I want. So it's technically not a query. If I don't give it a query string, I get a web page. See? So by default, I get web pages. But if I tell it I want, notice the question is called the query string, but it's really, everything in the internet is a lie. Notice how the parser says that that's the query string, but in this case, it's not a query. It's really a format parameter saying, don't format the output as HTML, format the output as JSON for me. So I get back a JSON file. So the query is actually over here. I'm querying the second person in the Star Wars API. For example, I can change people to planet. Now I get the second planet. Whoops, I deleted oh, I thought it was planet. Let's see. See, I forgot the API already.
It shows planets plural.
Oh, planets plural. Oh, okay, thanks. Planets. People. Yeah, people. Yeah, people's plural. So planets there. Okay, so the second planet in the Star Wars universe is Alderaan. Okay, so there's the query, and what the URL is calling the query is a format parameter. So people abuse the terminology all the time. Unfortunately, we talk about the query string in a URL. The query string in a URL doesn't have to be a query, it can be a parameter. Sometimes the query string is a query, sometimes the query string is just an arbitrary parameter. Things get really messy real fast when you work on the internet because everybody lies and everybody abuses terminology. Okay, so technically, this part of the URL is called the query string. Because if I look at my Java code actually asks Java for the get query. See, that's officially what that question mark is. It's the query string in the URL. But the query string in the URL does not have to be a question. It could be a command. In this case, it was a command telling the server to send me data in JSON format instead of HTML format. All of this is a mess. Everything is, everything's got a name. You got to know the name. And then everything the names are always abused. Okay. Like here, the authority seems to be redundant with the host name and the port. I don't know why they call the host name and the port combined the authority. I don't know where that terminology even comes from. But we saw it in the others that the combination of a host and a port is an authority. the term host and the term port are used all the time. I rarely see people use the term authority. But the authority is well, in this case, the authority is just the host, because the authority, in this case, we didn't give a port number. But in this case over here, the authority included the port because we explicitly gave a port number. So again, there's terminology. The terminology is part of the code. See, there's get authority. If you go read the documentation for the internet, they'll tell you what an authority is. They'll tell you what a query is, but you have to be real careful. The query is just whatever comes after the question mark. That doesn't mean it's a query. The query doesn't have to be querying. The querying can be telling you something, like in the case where it was what we did here. This query didn't ask something, it told us something. It told the server use JSON, not HTML. So that's what makes this stuff kind of hard. You learn the lingo, but then you have to realize that it's all kind of fluffy. It's all kind of fuzzy. The way people use the words, the way people use the jargon can really vary. Okay, now these are called URIs. There's also what are called URLs. Let me turn off the beeper. Just real quick, you can also parse URLs and you'll get different answers. The same URL, these URIs and URLs again are a mess. Technically, okay, everybody calls these URLs. Technically, they're URIs, but nobody calls them URIs. So in your web browser, up here, people will always call this the URL, but it's technically the URI. But nobody ever calls it the URI. Everybody calls it the URL. If you go down here, you'll see that the URI parses different than the URL, even though it's the same thing. And it's just a mess. Technically, they're URIs. And in Java, we shouldn't be using these methods that get URLs. Where is it? See, shouldn't be using this. Should be using this. I'm constructing a URI object. That's right. Here I'm constructing a URL object. Shouldn't do that. Java has it. It's there because everybody uses the URL phrase, but you're not supposed to construct URL objects. They're essentially obsolete. Nobody uses them anymore, but they call them URLs. This stuff gets really messy really fast. Okay, so your browser, everybody's going to refer to the browser bar, the address bar, as a URL, and you should always think, but it's not really a URL, it's a URI, and URIs and URLs are not quite the same thing. Okay, we'll quit there. There's a few other files in this folder. We haven't actually created a connection where one computer talks to another computer. That's these. Retrieve URL, retrieve URL. Notice it says retrieve URL, but it's not retrieving a URL, it's retrieving a URI. Okay, well, we'll start with these up next week. That's where we actually connect to a computer and get that. We actually make, that's when we'll actually make a internet connection from one computer to another and get some information. Anybody got any last minute question, anything? Oh, I'm supposedly recording this, and if the recording went through properly, I'll put the recording up on the course website. So if the recording worked, and I really do get a recording file out of this, I'll put it up on the course website. So if you want to look at this again, you can look at it again. Anybody got any last minute question, anything? Okay, so I'll stop the sharing and I'll stop the connection, and have a nice weekend and stay out of the snow if there is snow yet. I think there is by now, but stay out of the snow. Bye.